Hey everybody, welcome to another episode of React Wednesdays. My name is TJ Van Tol. I work as a developer advocate at Blues Wireless. And if you're new here, React Wednesdays is a stream that we do every week. We basically bring in cool, interesting people from around the React and the JavaScript world, and we have them teach us something really interesting. It is telerik.com/react-wednesdays that you can check out. If you're watching this on YouTube, the link should be down in the description if you want to see who we have coming up on the show, upcoming episodes, or browse old episodes, that sort of thing as well. You can check that out. Now, for today, we have an exciting topic. At least I find it exciting because it's something I've dug into before and been confused about, and that is React server components. And to talk about that, I'm going to welcome Chung Wu onto the show. Chung, welcome to React Wednesdays.
Hi, great to be here.
You want to tell people just who you are, what you do, that sort of stuff?
Sure, yeah. My name is Chung, and I'm one of the co-founders at a company called Plasmic. We build a visual builder for React. So it's kind of a design tool where you can visually design your React application or website, and it will generate React code in a way such that you can really easily integrate it with your existing React stack. And this basically empowers non-technical folks to build their own landing pages or storefronts using React components or code that your developers have created. So I'm not an expert on React Server components, but I was very curious about how it worked, and I just started reading code and dug into it. So here I am.
Well, I think though, like the fact that you've dug into it makes you a bigger expert than 99% of people out there. Because I think most people either don't even know what it is, or have just like me, just like looked at the absolute basics and got kind of confused about it and said, like, well, let's just wait and see how this how this plays out.
Yeah,
So
like when I first heard about it, it just sounded so much like magic, and
yeah.
whenever I kept trying to read more and more about it, but a lot of it are a lot of the content out there is kind of like restating what was in the RFC, which is great. Like it's very helpful, but still it still didn't really like click in my head how it really works under the hood, and that's why I decided to read some code, I guess.
So maybe you could start by just for people that have never even heard the term React Server Components. Maybe you could just start with what is it? Why at an extremely high level would you care or be interested in it?
Yeah. So the way React component works usually is that you have a browser opens up a page, and then you load some JavaScript bundle, and that JavaScript bundle has a bunch of React components that you've wrote, and then your code would basically use these React components inside the browser to render your application, right? So this is when React, in the simplest case where React is maybe being used to build your single page app, you would just download the bundle, render the application, all on the client side. You might make an API request to the server to get data to help you render the application, but everything's happening on the client side. This works fine and for that use case, but increasingly, people, there's a lot of effort to start moving things to the server side, and for a lot of different reasons, but some practical reasons are just, for multi-page apps like marketing sites or e-commerce storefronts and so on. It's important uh, for the server to be able to render all this data. It's called server-side rendering, so that all this your page will arrive with all the HTML already, and then your client-side JavaScript will just hydrate that content instead. But there's a lot of issues with that too, because in this framework, you still have to download a ton of JavaScript to the client side to do the hydration. So to back up a little bit, like to do hydration, right? You basically, the server kind of simulates a client environment to render your React application, and then generates the HTML, sends it to your browser. Your browser then loads all the same JavaScript bundle into the browser, reconstructs the React tree, and then tries to attach it to the DOM that was already embedded in the HTML. So that means that this server-side rendering, client-side hydration trick does help you get some HTML on your page earlier, but you still have to go you still have to have all your React components on the client so that you can do this hydration. You're still rendering everything again on the client. So it's really kind of a trick. So how do you make this process even better, right? Some of the things that you're doing are actually better done on the server than on the client side. So for example, when you're fetching a lot of data, your servers are often, more collocated to your data sources, like they're running in the same availability zone and so on. It's easy for your server to grab a lot of data all at once. Or maybe sometimes you're doing a lot of expensive transformation of the data, like if you're turning Markdown into HTML, or that's kind of the example React team used, or whatever kind of expensive processing that you're doing that requires a lot of JavaScript. You may not want to have to run it on the client side because you have to download all that code to the client and run all that expensive code to do the transformation when you can just do it once on the server. So anyway, so there's like a few things that the server is really good at, which is loading data more quickly and also using expensive, heavy dependencies that you don't want to download to your browser. On the other hand, there's a few things that the browser is really good at, which is, all the interaction that you need to be able to do for your app, right? Like when the user click on this, something needs to happen and so on. So all the browser side interaction needs to happen on the browser. So what React Server Component allows you to do is to basically take your React tree and then you can break it up so that some of the components are being rendered on the server, and then some of the components will be rendered on the client, so that the server can do what it does best, which is fetching data, doing expensive transformations, and the client can do what it does best, which is attaching behavior and interactivity. And so you can have this separation, division of labor between the server and the client to render your app.
Yeah, it's funny because thinking about my career in software development, it's this pattern, or how much we use the client and server, has drastically shifted. Because the first apps I wrote when I first got like a job in software world, everything was server rendered, right? Your backend, you had some Java or .NET or Perl or whatever PHP backend, and
Right.
that thing spit out. Its job was to spit out HTML, and it might have some JavaScript to do like form validation or something like that. But that was like the extent of the JavaScript you use. That was like all server. And then like we started realizing the benefits of JavaScript. So then we kind of went like this single page app route, right, where JavaScript was everything, and you shipped all of your JavaScript, and it drove the entire page, the entire process. And I feel like now we're at a phase where, and React Server Components is like the ultimate expression of this, where like we're realizing that both have their benefits, that the backend does some things better, the client side does some things better. And so you have frameworks like Next and Remix that try to mix and match, but React Server Components, like, to me, takes it to the next level and just lets you do things at a really, really granular level for that sort of thing.
Yeah, it's interesting how, yeah, exactly. Like we went from all server to all client. And then there were so many hacks to make all client kind of work in the, like, remember, like we used to have these hash bang URL
Oh yeah.
fragments and stuff that we add to our URL so that search engines can find the content and all sorts of stuff to kind of, and then we're slowly moving back to like this mixed world that you're talking about. And there are a lot of frameworks are moving in this direction too. And just pure React without server components, still great for single page applications, heavily interactive and all that kind of stuff. That still makes sense. But as you move more towards kind of the kind of sites or page where a page is a thing that makes sense, like a URL is a meaningful thing for your app, then it starts making more sense to kind of think about, for each page that you're rendering, what can be done on the server and what has to be done on the client.
Man, hash bangs bring back memories. I hadn't thought of that in many, many years.
Yeah,
It's
yeah.
back from the Backbone days. Like, well, I'm curious more about the APIs. Is this a good time? Do you want to bring up like some? I know you had some demos and stuff you wanted to show off. This might be a good chance to sort of jump into that, because I think like React Server Components is one of those things that's hard to talk about completely in the abstract, just because Like when we talk about mixing server and client, like my mind immediately wants to go to, well, how specifically does it do that? How does it accomplish that? What does it look like? That sort of thing.
Yeah, let me share my screen really quick.
And while Chung is bringing that up, if you in the chat have any questions, feel free to drop those in really at any time during the stream, and I can pass those along too. And yeah, I see your screen, so I'll go ahead and bring that up.
Cool. Yeah, so I think first I'll be a little more specific about how we're trying to divide up server and client. I think it makes a little more sense to have a high level picture of how it works before we dive into some code, and then
Yep.
you'll see like how it actually comes to be. So you have this typical React tree, and usually each of these circles is a component, and usually you just have components instantiating components and so on. And you basically want to turn some of them into server components to be rendered on the server, and some of them, the blue ones, are the client components that you want to render on the client. And the high level strategy is basically, because some of it is rendered on the server, some of it is rendered on the client, you have to first kind of start with an API request to the server to, hey, render me this page. And the server basically starts with the root server component and then tries to render it as much as it can. So basically, whenever it sees a server component, it will call that render function to turn it into either a bunch of base HTML tags, or into other instances of server components, or into instances of client components. Whenever it sees a client component, it goes, oh, I'm not supposed to render this. So instead of rendering that client component, it just uses kind of a placeholder here. And the placeholder for a client component just basically has, what is this client component and what are the props I'm supposed to have? So in the end, the server basically turns your React tree into something like this, where the server components have been turned into tags, and then the client components are just kind of placeholders to be filled in by the browser. And then the server kind of sends this tree over to the browser. And then the browser takes that tree and then basically takes that JSON blob and tries to reconstruct the React tree. So it knows that, oh, there are some base elements here, and then wherever it sees a client placeholder, it goes, oh, I need to turn this into an actual client component instance. So it looks up where that client component function is, and then swaps it into place so that it builds this full React tree in the browser. So the interesting thing to note here is that the browser doesn't see any of the server components at all. The browser just sees the tags and also the client components that those server components rendered into. To the browser, all there are tags and client components. So it's this division between server and client components that this and this handoff that happens.
And how much is React doing this under the hood, and how much is like, am I as a developer controlling which is which here?
Yeah, so you need to tell React what is a server component and what is a client component. And the way you do that is by naming your files a certain way. So the server components are called, component.server.js, and the client components are called component.client.js. And this way, you as a human can easily tell, oh, these are meant to be run on the server, these are meant to be run on client. More importantly, the bundler is able to tell which components are server and which components are client. So the bundler actually plays a really important role here in this dance between the server and the client. When the server was building the partial React tree here, the bundler is the one that kind of goes and swaps all the client components with just kind of these references. So the bundler is able to kind of grab for the files that ends with .client.js, and then kind of when you import from those files, instead of returning what's actually what's actually exported from those files, it just returns, it just lets you import just like these opaque reference objects that are serializable and can be sent to the browser. And then similarly, on the browser, you use your bundler's runtime to figure out, oh, I got this module reference. Tell me what's the actual JavaScript function that I'm supposed to be using as the client component. And the bundler runtime can either go fetch it from the server or already has it and then swap it in.
So is this with the bundler here? Is like presumably the React team has some sort of implementation of this? Is it like a fork of like a bundler we know? Is it something like completely custom? Like what is it? I'm guessing it's some sort of experimental or beta like something, but like what is it specifically? Do you know?
Yeah, it's actually just kind of like a plugin for Webpack, for example. So, you know,
Okay.
so for each bundling framework, there will need to be some plugin that will make this work for that bundler. So
Okay.
React is officially working on the Webpack one with Next.js, but Shopify, who also have a React Server component-based framework called Hydrogen, they're working on a Vite-based version of this plugin for Vite.
That makes sense. Yeah. In my head, I was thinking like it had to be something that was specific, but I guess it's just some way of manipulating files around. So, in theory, any bundler could do it as long as somebody wrote the code to do it.
Yeah, it's kind of uh, it's kind of astounding that this works at all. But yeah, that's a lot of bundler tricks you can play there. Yeah. So um, because of this dance, there are some rules to how the server and client components can work together. There's a long list of them on the RFC, but probably the most interesting one is that a client component cannot import a server component, and that's just because all the dependency graph of all the client component code is going to be bundled and sent to the browser. So if the client component depends on the server component, that means that the server component code needs to be sent to the browser too, and that kind of defeats the whole purpose of being able to only send client stuff to the client and keep the server component stuff on the server. So client components can instantiate server components because they can't import it, but still you can see trees like this where you have kind of client components and server components interleaving. And that's because even though this client component, for example, is not directly instantiating this server component, you can still do this interleaving via just normal composition, where basically, you pass React elements in as a prop to another React element. So for example, this component can pass these two components as props to this component. So this component, a server component, can import and instantiate these two components and then pass them in as prop here. And this client component just take those props, just those, React node props, and then just renders them. It doesn't really know what's in there. It just renders them like the children prop. So that's how, so this is an interesting thing to think about, that, if you want to do this interleaving, you have to think about how the server components gets created. They always have to be somehow created from the root server component and then passed in to client components if that's what you want. And that can lead to some interesting ways that you have to kind of organize your component code.
One thing I'm very curious about, and we'll probably get into this when you start showing some specific code, but I'm very curious what the tooling situation is like. Like how much am I like if I break one of these rules of client server components, like am I gonna get a nice error message, right? Like is something am I gonna get some confusing situation or like I mean even better if like me, like I've been spoiled by React and VS. I mean, it's one of the reasons why a lot of people like it is because the tooling is just so good. And I mean, I'd love it if I tried to import a server component from a client component and VS Code popped up something and said like, "Hey, can't do that because of this reason." But I'm guessing my gut tells me though, since this is early days, it's probably a little bit of the Wild West right now. Would be my guess.
Yeah, tooling definitely has a lot catching up to do. Uh, VS Code won't right now. I think there's nothing for VS Code to warn you about.
Yeah.
But the bundler plugins will warn you about it. So
Oh, okay.
when it's trying to bundle the code and it's trying to and it's trying to render on the server, when it encounters unexpected things, it will blow up, and you will at least know you're doing something illegal.
That's good. It's better than expected. And like I mean, like this is it still considered beta, like experimental? Like I don't know what term React officially uses, but like I know it's not like in any way official. So like that's the sort of thing you expect to be rough at this point too.
Yeah, I think it's definitely not ready for prime time. Like first, it's still under active development, but also um, frameworks like Next.js and Shopify Hydrogen are still kind of iterating on how they want to incorporate React Server components into their respective frameworks too. So those are still very active and changing all the time. So it's a space to definitely keep your eye on, but it's not quite ready yet.
Yep.
Yeah, just yesterday I was trying to set this up for set up a demo with Next.js and React Server components, and it wasn't working in the latest version. I had to revert back a few versions to get it to work and stuff. So, yeah, stay tuned, I guess. Yeah, maybe I can just like show a quick example of how this might work.
Yeah.
Okay. So this, I have like several examples, several setups for the same example. So in this setup is kind of based on the official React Server component demo that the React team put out, where they demo like having a note-taking application using React Server components. So this is an interesting demo because it's purely React Server components. There's no server-side rendering involved at all. So when people talk about React Server components, they often also think about server-side rendering, and that's because they sound so similar. Both have the word server in it, and they both are doing work on the server, but they're actually totally orthogonal features from React. One is about doing this division of labor between server and client components, which is React Server components, and then React server-side rendering is about the server simulating a client environment to kind of trick the React component into rendering into HTML so that it can get the HTML out of it. So
Yep.
they're actually totally orthogonal, but they are kind of intricately, they will almost always be used together. But it's easier to understand them if you understand them kind of separately before you put them together. So the official React server component demo is a great place to start because it's purely React server component. There's no server-side rendering mixed in, so you don't have to think about that at all. So the React server, so this component, this app works just like how any single page application will work. Your HTML just has a script tag that will load some JavaScript that runs to build your React application. And so here's the root of the application on the server side. So on the server side, basically, here's an example where you're importing a component that is a server component. So this is how you can tell, that the dot server there really just it makes it very obvious. And I think that's one of the reasons why it was a good idea to just put the server and client extension on the file name, as odd a choice as that might seem at first. And so this root component here is a server component, which means that this is a component that the server is going to be rendering. And then it can, as a server component, it can instantiate any other server components as well as client components. But let's just dig in here. Okay, so tweets list is a simple component. It just loads a list of tweets and then it renders them as a list of cards. So this is actually, this is fetching the tweets and it's doing a suspense. It's doing the fetch in a suspense way. So which means that, it's going to check a cache, and if there's no data cache, it's going to do the fetch and then throw the promise, and then, and then once the promise is resolved, the React will know to re-render this component, and in which case, the second time you try to fetch, it will hit the cache and then get data and stuff.
Yep.
Suspense is its own big topic.
Yeah.
We probably can't really get into, but just suffice it to say, this is a fetching data in a suspense way. So it's going to throw a promise if there's no data, and then once the data is resolved, it's going to re-render. Once the promise is resolved, it's going to re-render. So that's why there's no fetching and use effect and stuff. Okay, so then we're going to for each tweet, we're going to render it in this tweet card, which is a client component. So why is this tweet card a client component? That's because I want this component to be able to attach some behavior. So for example, here, I want an onClick handler on the button. These are the kind of things that you need to do in client components and now server components. But this tweet card will also display the tweet content, which for the purpose of this demo is in markdown format, just to make it. So let's say the tweet body is actually some text in markdown format, but you want to do this transformation between markdown to HTML on the server and not on the client. So whereas normally, maybe you would write the tweet card like this. Tweet card, right? And then you would do something like, so for the tweet content, it's going to be like test with markdown.
Oh yeah, and have like a component that like does the transformation client side sort of thing.
Yeah, right. So usually
Okay.
you would be doing like, so tweet chip, user chip, user equals tweet user or something. So normally you would this is kind of how you would logically, I think, structure this component. You have a tweet card component, you get a tweet data object, and then you just do all the rendering you need to make it happen, right? But if you don't want text with markdown to be in the browser, so text with markdown is just doing some, it's just transforming the content from markdown to HTML. So if you don't want to load that library in the client, then you cannot be importing this component or instantiating this component from this client component. Instead, you have to rely on composition, which means that some server component needs to do that transformation and then pass the result of that transformation in as a prop. And that's why you kind of have to, that's why I was saying this forces you to rethink how you architect your components, because the server client divide is going to be a very big part of how you think about how you're dividing up your component. Now your tweet card component can't be responsible for rendering the content of the tweet anymore. It has to be passed in as a prop.
Yeah, it's interesting because I can see the benefits, right? Like you're doing the, I guess, the some logic that would normally take like shipping a library to the client, and also like a server can run that code faster as well on the server. But at the same time, like it does introduce some complexity into your code, because normally you would just assume the client's doing all of this and do it. But instead, now you have like some decisions to make. And so it's sort of like you get some performance, but at the trade-off is a little bit more complexity in the app that you're writing as well.
Yeah, absolutely. The server and client divide is really going to be very forefront in your mind as you're writing your application now, because you always have to be careful about straddling this divide. So that's why this tweet card is taking in tweet content as a prop instead of just rendering it itself. It's also taking in a tweet user, and that's because, oops, where am I? Yeah. Okay. It's also taking in tweet user as a prop because I want to kind of go, so tweet.user is just a user ID. So if I want to say now to do another fetch for the user's name and handle and avatar or something, I have to do an additional API call. And I don't want to do that API call on the client either. I want to do that API call on the server because I kind of want to do all my data fetching on the client server. So that's why I have to, again, kind of extract that out of the client component so that I can use a server component, which this is, to render something opaque element that I can then pass into the client component as a prop.
Yeah, it's interesting. It's basically a completely different paradigm.
Yeah, you really have to think about it, and it will take some getting used to, I imagine. So if we just dive into this component really quick, it also just basically, you'll probably also have a lot of these kind of paired components where there's like a server component that is doing data fetching, which is this one, and then a client component that's going to use the data that you just fetched. So here's a server component. It just fetches the information for the user, and then it passes it in to this client component. And this client component then just, renders a button because it wants to associate some on-click handlers and stuff. That's why it's a client component. So this will also probably be a common pattern where you're wrapping a loading server component with a client component so that you can do that divide.
I'm assuming too, it's kind of slick how this integrates really well, or at least it seems to integrate really well with suspense. Because I'm assuming like part of the benefit or the reason you do this, I'm assuming when this page loads, you're going to see like something right away, but the data is going to get like asynchronously hydrated in there on the fly, sort of thing.
Yeah. So that's see it. Okay. So here's the ugly version. So I'm gonna load this now. So here's a tweet card, and this is the tweet content, and then this is kind of the tweet user chip. Okay, so I'm gonna load this, and I obviously slow down the data loads to like 5 seconds so you can see.
Oh, nice.
So loading.
Yeah, that's really slick.
Okay, and then it goes here, and then once this the user chip loads in, then this pops in, right? So
oh yeah, that's slick.
That's because I had for this tweet user, the fallback was just a user ID, and then it becomes this button. So you can tell that first it was just @Kevin, and then it becomes this button. So anyway, it comes in with multiple. So actually, great. So let's take a deeper look at how that actually worked.
Yeah, I'm curious. And by the way, you have a friend in Twitch chat as well. I Colin Thompson says is happy Plasmic is on Twitch.
Thank you.
And also, your camera randomly stopped at some point. I don't know if you did that on purpose or not, but
I did not. Ugh. Let me see. I can click. Let me.
If not, I don't know if you didn't. If not, it's not a big deal. But that was just very, very random.
Oh, did it start again?
It started, but it's kind of frozen. So maybe just stop it and just keep going. It's totally cool. It's just kind of weird.
All right. Yeah. My.
I think your webcam is frozen, so I would just hide it.
All right. Cool. Let's just keep going. Okay. So here are the API requests that were made from the browser. The interesting thing is this one.
Yeah.
And that's the one. So this is basically hitting an API endpoint on the server, which I can show in a bit, to say, okay, now I need to. The client basically says, okay, my job is to render whatever React content you tell me to render from this API endpoint. And then the API endpoint responds with this weird format, which we call kind of the RSC wire format. And it's actually, it looks weird, but it's actually very simple. It's just a way to send chunks of JSON blobs identifiable by some ID. So, for example, so these markers here, the S stands for known symbols, J stands for a React element tree. So here's a tree of React elements. And then M stands for module reference. So if you're looking for this module, you can find it in this chunk and from this file, and this is the export name. So this is basically instructions filled out by the bundler to tell the bundler runtime on the client where to find this component. So we can dig into this J0 a bit. So first, we receive this chunk, which is J0, and J0 says to basically render an H1 called vanilla RSE, which is what we see here, and then a suspense boundary with the fallback of loading, and then the children for the suspense, which is what happens once the promise is resolved, is at2. So at2 is kind of how it references what's to come. Sorry, references other blobs of other JSON blobs in this stream. So
Yeah,
the interesting
it's
thing,
like the placeholder.
yeah, right. The interesting thing to note is that two, we don't know what two is yet. So all the client can do at this point is to render the fallback. And then this is a stream. The response is going to come in, one chunk at a time. So next, this chunk tells us, oh, if you ever see a reference for M for 3, here's how you resolve it. And then, oh, and by the way, here's the chunk for 2 now. So remember that 2 you were waiting for? Here it is. And then this just gives you, both the data that we just fetched and also just like a bunch of other React elements that we're rendering. Um, but these also has more references, right? So here's, for example, this is the tweet user chip that we were looking at, referencing at 4, and 4 just comes in here. Here's the full data for that and full data for that. So there's kind of a stream. The reason why it's a stream with chunks, and these chunks corresponds to the suspense boundaries, and that's why the suspense and React server components are kind of intricately intertwined like this.
Yeah, I think this is like long term where more like officially supported debugging tools will probably be able to help the situation, just
Yeah,
to not rely on some knowledge of these symbols, but instead show like a polished representation of this.
yeah,
Eh,
for sure.
I'm also wondering, like, as you've experimented with this too, how is like debugging in general? Because I was also wondering, like, so say something goes wrong with one of those fetch calls, right? You typoed the URL, or whatever the case may be, because then that call is running on the server, right? So your browser log would like never know about that. So it's
Hmm.
presumably would be in like whatever's triggering your server. Have you found that strange to work with? Have you gotten used to it?
Yeah, so I think the official way to deal with it is to have when your promise is throwing an error, uh, it's going to be caught by your error boundary. So you need to have an error boundary in your React tree that will catch it and then render the right thing when there's an error. But yeah, the error is happening on the server, and the client will be no wiser. The client would not know something has gone wrong unless you had handled it with the error boundary and is passing down the right thing to render in the stream.
So do error boundaries still work as you'd expect, even with this client server sort of setup?
Um, yeah, I think
Okay.
so. I haven't actually tried it, uh, but yeah,
That's interesting. It's just things like that I wonder about. I suppose though it's not too different than like what people are doing with like Next.js and Remix today, because you already kind of have in a lot of apps a situation where you have usually it's through server rendered stuff in production apps today, but you already still have a bit of like some stuff running on the server, some stuff running on the client. So I guess it's not that uncommon of a problem already for people to deal with.
yeah. I mean, yeah, to the extent that they deal with errors at all.
That too.
Um, yeah, so that's kind of just vanilla RSC where you just use React Server Component. It's interesting to uh, you know when you kind of think of your server rendering endpoint as just an API call, you know, whereas before your client component might hit an API endpoint to ask for the list of tweets, and then hit another API endpoint to ask for uh, the full user information for this user ID. Now you're hitting an API endpoint that would fetch all that and then give it to you in the form of this format, this React wire format. So it's not like you're getting away without an API call. It's just that the API call is now outputting things that's very, very specific to what you're rendering to the screen.
Yeah. Which is cool because that means the server is doing it faster and doing the parsing for you. So, because the browser can interpret what you see there faster than it can do the multi-step of getting the data and having the client parse through it and such.
Yeah, it could also make a lot of sense if what you're actually rendering is only a small slice of the data that you needed. So you might actually be sending down a lot less information than if you're making full API calls. But it kind of depends. Sometimes it's going to be better, sometimes it will be worse. Yeah, it will be a trade-off on the data fetching side.
Yep.
The React Server components, there's like the related topic of server-side rendering, where you would actually just kind of render all this on the server and send it as HTML to the client, right? And React 18 actually has big news on that front too, right? Now it's also going to start supporting streaming server-side rendering, which can work with suspense. So previously, server-side rendering does not do suspense. The rendering is synchronous, but now it's able to deal with promises being thrown, and it's going to be outputting a stream of chunks of HTML instead of just one full HTML document now.
Yeah, so firsthand I've ran into, because I mean the downside of server-side rendering kind of like is it usually is kind of, I think for most people, like an all or nothing proposition. And if you have a lot of data, then even though the server is doing all that work, there can still be a few seconds before you ship that, because the server still needs to do a decent amount of work before the user sees stuff.
Yeah.
And I mean, I'm quite literally working on an app right now that has that problem. And so we're starting to explore other ways of like being more dynamic, taking advantage of some of the newer React stuff to try to find a way around that. Because the server is very fast, but if it needs to get data from like 7 or 8 different places, that still takes time.
Yeah, is it slow because of I/O, like the fetching data, or is it slow because it's
The fetching itself is slow, and so we need to do a better job about making sure the user sees something immediately, and then the data seamlessly comes in. Which
Yeah.
it's a solvable problem. It's early in the EPS. We're just starting on it, but it's still just it's like things like this are trying to make that sort of, because I think it's a really common situation, is trying to make that sort of thing easier to solve out of the box.
Yeah. Right. So with server-side rendering, with the streaming server-side rendering, it will be able to respect your suspense boundaries. So if you're doing some data fetches are fast, some data fetches are slow. So you can start rendering the parts that are fast first and then just kind of have the suspense fallback rendered while you're waiting for the slow data to come in.
Yep, we're gonna have to play with that.
Yeah, I have a quick demo. It's for basically the same app, but going over kind of streaming SSR. So there's oops. Oh, well, yeah, that happened instantaneously, but maybe we can look at the request here.
See it so fast, you just see everything right away.
That means something must be wrong. Oh, there we go. Okay. And this is just to show, like, it's actually, yes, something is wrong because it is way too fast. Let me see.
Yeah, and while Chunk's looking into that, if you do have any questions, feel free to drop that in the chat as well. Anything else you want to see us cover? Because I know I found this super interesting.
We can just slow it down some.
So on the back end of this, right, you've got like artificial delays, right? Yeah.
Okay, let's see. Oh yeah, there we go. So this is actually chunks of HTML coming in. So that's the next chunk. And then there's going to be the users coming in. And what you see in the HTML is something like this, where there's basically one chunk here, and then, maybe I'm going too fast. Yeah, so first you see this streaming SSR, and then here's some loading, and then here they output another placeholder where it's just like, okay, there's data that's going to come here. It's not ready yet, so I'm just going to output this with an ID, and when it's ready, please swap it in here. And then there's some more stuff here where just like waiting for data to show up. And when data do show up,
Yeah, it looks like it's getting the template and doing
right,
like hot swapping it in essentially.
yeah, these functions are basically going, okay, the data is here, so swap this in for that DOM element. And so you see even in the HTML, so this is not even like client-side hydration or anything, like just in the raw HTML, you can see that the content is being loaded incrementally.
Yep. So is this using React server components all, or is this just straight up SSR with React 18?
This is just straight up streaming SSR with React 18 and with suspense boundaries.
Okay.
And suspense for data fetching. It really gets the most interesting when you combine both React server component and streaming SSR, because so these two things are orthogonal features. They don't know about each other. React server components don't know about streaming SSR, and streaming SSR doesn't know about React server components. And the way, if you think about using them together, like if you just have a server component tree, right, and then you have a React component tree with a bunch of server components in it. If you just want to stream that to the client, it doesn't work, right? Because consider what happens at hydration on the client, right? When the client receives this DOM element and needs to do the hydration, it cannot it doesn't have the server components to be able to rebuild that same React element tree to do the hydration, because the whole point is not to send the server component code to the client. So you can just stream a server component stream. Instead, what you have to do is kind of compose React server component with streaming SSR. So first, you on the server side, you would take the React tree, and then you would turn it into the React server component RSC wire format. So you would stream the server tree into a wire format, into a stream of the RSC wire format, just on the server. And on the server too, you start reading that wire format and into a React element. So this is all happening on the server. So the server is converting the React server component tree into a tree that is more like this, right? So we start with this tree, and then we do the React server component thing and turn it into this tree where we just have tags or client components. And then we server-side render that. And then when the client is hydrating, it's also hydrating this tree and not the original tree. So the client, when it's doing the hydration, also only needs access to the client components and not the server components. So it's kind of interesting how they compose together, and this composition is actually happening not inside React, but in userland, and the frameworks like Next.js or Shopify are the ones that's doing this composition to make this work.
Yeah, that was going to be my next question, because that sounded like a lot of work.
Yeah, yeah, the frameworks will make it seamless, right? But what's under the hood is really interesting.
Yeah, because I could see like it'll be interesting to see what sort of APIs these frameworks can come up with to try to make that easy and intuitive and like also like debuggable and stuff. So it's kind
Yeah,
of cool though that there are multiple people sort of attacking this problem with these underlying APIs. I think it's one of the the good things about the React ecosystem lots of times is React tries to tackle fairly like low level problems or doesn't try to do too much, which kind of can lead the community to kind of experiment and ideally find the approach that works the best or is the most sensible to most people. Because I can sort of get a lot of this, but I am no React expert. Like I don't like know these APIs in and out. So for me, like if this call ended and I was tasked with implementing this into a real app, I would have a hard I would have a hard time to
Oh
be
yeah.
honest with you,
No,
right?
no
Like it's
one.
it's not it's not easy stuff.
It's not, and yeah, even the frameworks are kind of iterating on how they want to do this composition. Right? There's a lot of details to get right. No one should be writing this code. And yeah, to
Yeah.
that point, React is really the team is really good at finding the right low-level primitives to build for that the community can build upon, which is both a point of frustration, but also why it's so powerful.
So that brings me to one question I did want to make sure I asked you is the state of React Server components right now, like presumably it's something that is still like an experimental only mode. Is it something like based off your experience, like should you be shipping any of this? Should you be playing any of it with this? Like where is it at in your mind today?
You should definitely not be shipping anything real with this. Uh, I think it's still got a ways to go. Like even as part of React 18, it's not. It's still like alpha or beta or experimental or whatever the term is.
Yep.
Uh, so and the frameworks are still actively trying to figure it out and make it work. And there's still a lot of unknowns. There's still a lot of problems that they're trying to solve, like both in, you know, how do you embed the RSC, like in this streaming plus RSC scenario, how do you embed the RSC wire format in the stream, in the HTML stream so that the hydration works? Or like how do you bundle the client components so that you're not breaking every component into its own bundle, but then the right one, like how do you optimally bundle your client components is also a little unclear. So this is like there's like a ton of active work on RSC and both inside core React core and also in the frameworks.
Yeah, because I imagine even if you wanted to deploy something like this, like I imagine even like the hosting situation would be interesting because you have to have a server. Like presumably there's something about the. Well, I guess probably any node hosting could probably do it, but like you have to
Yes.
have but your server still has to know like what it's doing in terms of like how to speak these APIs and such.
Yes. And actually, there's also some complication I don't quite grok about um, the node server being so to kind of basically activate this mode where the bundler will start replacing client components with module references, right? That's not something
Yeah.
that you want to have happen when you're doing server rendering. That's something you want to do when you're generating the RSC wire format, but not when you're doing server-side rendering. Like server-side rendering, you do want the client components so you can render the HTML. So there's also some even architectural work there to make sure that your node process knows which mode it's in, what task it's doing right now, and that's something the frameworks can take care of. But if you're doing it yourself, you'll have to think about it.
Is not ready for production, but this still seems like a cool. I mean, this is interesting stuff, like cool to play with, and I think especially if you're at a company where you're running into some of these problems, it might be worth just tinkering with. I'd say just to see what you think. So I am curious where I'm going with this. Is I'm curious, like, what's the best way? Like, how did you get started with this? Where would you recommend? Like, if people want to toy with this, are there any good like what's the best like tutorial or guide or demo or like we can point you have a blog post on this that I can drop I can find and drop in the chat real quick, but curious what other like tips and references you have for people.
Yeah. Honestly, the uh, Of course, you start with the RFC from the React core team that has all the ton of great information already. You can also find a lot of random pieces of wisdom in discussions and tweets, and as usual.
Yeah.
But with the React team, but it's it's hard to get a really good grasp unless you just dive in and start reading the code. And I do recommend that. Like, I actually think I was I was reluctant to do so at first, but it's like it's not that bad. And what was especially helpful was reading the code from both Next.js and Shopify Hydrogen, which just kind of helped me better triangulate like what is in core React land and what is in framework land and user land. So, but I think it's still pretty early, even in terms of like learning how to use React Server components effectively.
Yeah, I didn't realize. I've just been googling around for some links for chat while you're saying that, and I didn't realize like Next actually has like a page on their docs now about React Server components.
Yeah.
Which that is news to me. So I'm going to drop the link in the chat because that looks interesting to maybe play with and a slightly easier on ramp to people as well.
For
And you
sure.
said what was the other one? Shopify's. What was the name of that? Just so I can.
Shopify Hydrogen. That's the framework that's their React Server component based framework that they're building.
Okay. Oh
So
wow,
really cool.
they have their website is pretty amazing, actually. I always appreciate that. That's yeah. If nothing else, even if you don't care about this, you should check out Hydrogen's website because they have somebody who's got some fun design talent.
It is neat.
So Chung, we're coming up on the hour here. Is there anything like we've missed? Is there anything that you think is important about React Server components that we haven't touched on? Like any last tips for people and such?
I think just that, React Server component is definitely, it's early, but it's going to happen, and it will change how we write React applications. Like this is React's answer to smaller JavaScript bundles, less hydration, and less client-side rendering, and faster time to interactive, and all this stuff that you're thinking about and hearing about, and when you're considering Web Vitals and working with your React stack, like this is going to be the thing that will make a big difference for you. It's going to be important pretty soon, I think.
Yeah. Well said. And then last thing, if people want to follow you, keep up with you, Plasmic, any give me some good links for places to follow, things to check out. So I can point people there.
So my Twitter handle is at Chung Wu, although I don't post very often. Definitely check out Plasmic if you're into React. Plasmic is a really cool way to visually build your React site and applications. We put a lot of thought into how do we build a intuitive design tool that's kind of more like Figma, but then that outputs real React components and real CSS that you can use to build real things. So definitely check it out. We have a Slack community too around Plasmic that's active, filled with really great people. So we're also excited about what Plasmic is doing.
Cool. Yeah, it looks awesome. And I just tossed a link in the chat, and Nate Dunn is happy as well. He's joining us.
Thank you.
As well. Well, cool, Chung. Thanks so much. I really appreciate it. I definitely learned a lot. I feel like your last thing you said too, I think is kind of important, that this is something that we're probably going to be talking about for years to come, right? Because I feel like this kind of is the future. How fast it gets there, we'll see. But it's an exciting topic. So having some background on it is much appreciated. So thanks for joining.
Yeah, absolutely. It was a lot of fun. Thank you for having me on.
Yeah, and for everybody else, React Wednesdays, this is a show we do on Wednesdays. You can subscribe on YouTube. You can check out our website, telerik.com/React-Wednesdays. Link, if you're on YouTube, will be in the description, so check that out. Thanks one last time, Chung, and to everybody else. See you next week.
Thank you. Bye-bye.